So in this video, I'm going to be talking about the final design for my filter, which will also conclude my milestone 1. So this is the filter I talked about in the last video, which was based around two CEM3320 ICs. Now, this one is set up in the low pass configuration, and this one is set up in the high pass configuration. Again, you have a bypass switch for each individual filter, and then a series parallel switch. When they're connected in series, they are set up as a bandpass filter, and when they are in parallel, it's a band reject or band notch filter. The controls for the filters are quite simple. For each one, there is control voltage input as well as then an attenuator or voltage divider for that, a cutoff frequency control, a resonance control, and there's also a resonance control voltage. However, I've decided that I'm going to remove this when it actually comes to building or prototyping the filter. And there is also the 24 or 12 decibel slope control that I mentioned, which is just a switch that allows you to bypass two stages of the filter. That is one of the key things that is different about my filter compared to some of the others, and that's the control over that 24 or 12 decibel slope. So, as I've spoken about before, you would have your amplitude plotted against your frequency. And you would then have your base signal and a cutoff point. So let's say that is a full frequency response and then a cutoff point just about here. So by changing the depth of that slope, we could go from the 24 decibel slope, which would look something like that, to the 12 decibel slope, which would be much more gentle and include more of the frequencies that are being cut, which would just allow for slightly more dynamics and expression with the filter, which is why I chose to include that feature. Past that, though, this is mostly just a regular cascade filter. However, something I would like to note as well, because I didn't include any clipping diodes on the resonance path for this circuit, you can drive these filters into self-oscillation if you turn the resonance all the way up. So with the control voltage then for the frequency, you can actually use this as an oscillator to get a sine wave output. Whilst I'm unlikely to use it for this function, it is something that I can use if I ever want or need to. And that's where this rheostat being tied to minus 12 volts comes in, because that acts as a scale adjust, and then your CV input would control the pitch that it's oscillating at. There's then a high-pass filter on the output, which is pretty standard for most electronics, and that's on both of the filters, and I do also plan to include one on the main output of the filter as well. But other than that, that mostly concludes this circuit, and therefore my milestone 1 project.